If you've been following the monumental saga of Starship, you've witnessed two of the most spectacular sights in modern rocketry: the hypersonic re-entries of Ship 37 and Ship 38. Both were triumphs, surviving the fiery crucible of Earth's atmosphere to splash down precisely in the Indian Ocean. Yet, when the recovery drones gave us our first close-up views, they told two very different stories. Ship 37 emerged from its plasma bath glowing with a distinct, fiery orange hue, mottled with patches of white. Weeks later, Ship 38 returned looking like a battle-scarred veteran, dark, charred, but remarkably uniform and intact. So, what was going on? How could two nearly identical vehicles, flying almost the same mission profile, look so vastly different? The answer isn't a story of failure or success, but a brilliant, visual lesson in SpaceX's relentless design philosophy. The clues to the future of interplanetary travel are written in plasma and steel on the skin of these cosmic beasts. To understand the color difference, you must first understand the mission difference. These weren't just launches, they were experiments. Ship 37, which flew on Flight Test 10, was a flying laboratory. Its primary goal was to gather extreme data. SpaceX deliberately pushed the envelope, fitting the vehicle with experimental components to see how they would perform, or fail, under the most punishing conditions imaginable. The pronounced orange color was a direct result of this. In specific sections, SpaceX replaced the standard black ceramic heat shield tiles with metallic test tiles. During the 1,600 degrees Celsius inferno of re-entry, these metal alloys heated up and oxidized, a high-speed, high-temperature version of rusting. As ElonMusk confirmed, the red color is from some metallic test tiles that oxidized. Those bright white patches? They were areas where tiles were intentionally left off, exposing the underlying white insulation and sacrificial ablative layers to the plasma stream. Ship 37 was sent on a mission to test new ideas, and it returned wearing the very data it was sent to collect. Ship 38, on the other hand, was the final exam for the entire Block 2 generation of prototypes. Its mission wasn't radical experimentation, but validation and reliability. Armed with the data from Ship 37, engineers implemented a suite of refinements. They improved the attachment pins holding the tiles, enhanced active cooling systems in high heat zones like the flaps, and ensured a more uniform tile coverage across the vehicle's belly. The goal was simple: prove that the core design, when refined, could work as intended. The result was a resounding success. Ship 38 completed its flight with nearly 100% of its tiles intact. The dark, charred appearance was the clean look of a heat shield that had done its job perfectly, without the dramatic oxidation of experimental metals. It was the validation SpaceX needed before moving on to the next generation. This tale of two ships reveals a deeper truth. The heat shield is everything, as a SpaceX engineer explained during the most recent launch broadcast.
Indeed, Starship's heat shield is the linchpin to full and rapid reusability. We can't launch, land, refuel, and launch again if we have to spend months refurbishing the heat shield after every launch, like they did in the Space Shuttle program.
That single statement defines the entire challenge. The Space Shuttle was a reusable marvel, but its Achilles heel was its heat shield. After every flight, it took an army of technicians 9 months to inspect, repair, and replace its tiles. For Starship to fulfill its destiny of building a city on Mars, it needs a turnaround time measured in hours or days. This transforms the heat shield from a technical challenge into an industrial one. You don't just need better tiles, you need an ocean of them. And that brings us to SpaceX's audacious solution: the bakery. Down at Cape Canaveral, SpaceX has built a fully automated factory dedicated to one thing: mass-producing heat shield tiles. The scale of this operation is simply staggering. In just 3 years, this single facility has produced more tiles than the entire Space Shuttle program did in 30 years. The process takes about 40 hours to turn raw materials into a finished, flight-ready tile. This is how you solve the problem of scale. You don't just build a better rocket. You build a revolutionary manufacturing system to support it. While the bakery solves the production problem, an even more subtle and dangerous engineering challenge remained. To understand it, you have to think about the physics of a skyscraper-sized vehicle, enduring extreme temperature swings. The stainless steel hull of Starship expands and contracts as it goes from the cryogenic cold of its fuel tanks to the searing heat of re-entry. The ceramic heat shield tiles, however, do not expand in the same way. If you placed them edge to edge with no room to move, they would press against each other during these structural shifts and shatter. This is the crunch problem. To solve this, engineers must leave a small gap between each of the 18,000 tiles. But this creates a new, deadly problem. These gaps, however small, can act as channels for superheated plasma to seep through, torching the sides of the tiles and attacking the steel hull underneath. You can't have the tiles touching, but you can't have them apart. How do you solve a problem that seems to contradict itself? The answer, revealed during the latest flight, is a brilliantly simple and clever innovation, nicknamed the crunch wrap. Here's how it works. Engineers take a specialized, high-temperature material called Vulcan felt and wrap it around the edges of the heat shield tiles. When the tiles are installed next to each other, this flexible felt layer fills the gap. It acts as a perfect gasket, a thermal shock absorber. It's resilient enough to compress and expand with the ship's hull, preventing the tiles from crunching, while also being robust enough to block the plasma from seeping through the cracks. It is, quite literally, the genius in the gaps, as the SpaceX team explained.
It's just one of the ways we're continuing to iterate on this heat shield, getting towards rapid reusability. Hopefully it's going to help Starship live Moss. Everything is just going to get us to that end state.
The journey of Starship's heat shield, from the oxidized orange of a flying laboratory to the battle-tested black of a reliable vehicle. From the industrial might of the bakery to the clever engineering of the crunch wrap, is the story of Starship itself. It is a story of solving impossible problems, not one at a time, but all at once, through relentless iteration. Each flight, each data point, and each innovation is another step toward the ultimate goal. With a powerful roar from its engines and a shield forged in the fires of re-entry, the path for Starship to become a fully and rapidly reusable vehicle has never looked clearer.